So what we are going to do today is we will be going over Eclipse, which is an editor for developing Java code, and we look at some basic features which are required, which will help you run the Java code required for Hadoop later. While we look at the basic features, we'll also do some hands-on today, wherein we will try to write a class. We'll create an object of the class, and we will run a method of that particular class. And we will run a method by passing different kinds of arguments for different values of all the arguments, and we will see how we can actually view the output on the standard output here. Okay, that's the plan for today. And we will also look at data types in Java, various kinds of data types that are available, how we actually define a variable, and we'll basically cover all these aspects. The plan for tomorrow, once we get a good hold on this, is to move into concepts of inheritance and polymorphism and so on, wherein we will see, as I said in the previous session, how classes can actually interact with each other and start passing messages. But today the main idea is to get a strong grip on what exactly is a class, how do you declare a class, how do you create an object, and so on. Okay. So I hope you guys can see my screen. The screen shown here is actually the Eclipse editor. You can download it easily from the internet. It's just like another software installation. So once you install that, there is an icon something like this, like the blue moon, which is created on your desktop, and then you click that, it opens up this editor. And as you see here, there are basically three panels, right? This panel on the top right side is empty. This is where the source code is seen. The panel below is mainly for the output, which has the console showing where the output is actually shown. On the left hand side, you can manage your source code. Today I'll be telling you various aspects of the source code as to how to manage it in terms of packages and classes and objects and files and so on. So this is where you actually see your source code. As you can already see, there are two projects here already there in Eclipse. I'm not going to open any of them, but I'm going to create a new one. So the way you create a new Eclipse project, right? When you create a new Eclipse project, your main aim is that you're writing a new Java source code. So to create a new Eclipse project, you go to File, and then there's an option called New, and then you hit the option Java project. Here you give the name of a project name that you want to create. So let's name it as my test project 1. Okay, this is all you have to do. You don't have to do anything else. You don't have to bother about the Java version here. Yesterday we spoke. Day before yesterday we spoke about the Java virtual machine having different versions, right? So these are basically different versions of Java virtual machine. Typically we use 1.6 or 1.7 to develop code, but you don't have to worry too much about it. You just click on next, and then you click on finish. Okay, and you see that your project gets created here, and there's a small arrow here beside that, and if you click on that, the project expands. Basically what it has is the source code and all the external libraries that it uses. So the source code is the source code that you write, and as far as the system library is concerned, basically to run any code you might require some existing code that someone else has written, right? So for example, to print something on the screen, you just say print, and then you write within a string what you want to print, whereas the actual print function is written by someone else, the Java experts who put it as part of the library. So those libraries have been by default imported by Eclipse. So this is the source code, and the way we start writing the source code is we right click on the folder source, we go to new, and we say we want to create a new class. Okay, so this is how we create a new class. See, it already points to your source folder in the project where you actually want to create the class, and then you write the name of the class. The name of the class here would be, say, my test class 1. Okay, Don't worry about what superclass and interfaces are. We'll be going over that in this course shortly. You don't have to worry too much about it. You just name the class and click on finish. And it creates this class for you. When it creates this class, it also creates the file. And it's important in Java to ensure that the name of the class is the same as the name of the file. Okay, so the name of the class is mytestclass1 and the name of the file is mytestclass1.java. You see that the name of the class is the same as the name of the file, which is quite important. And by default, it has created this template for the class, which is public space class space mytestclass1. So this is how you create the class in Java, which actually Eclipse has done for you. What you basically do is you write the keyword class and then you name the class. We will go over some specifiers such as public and private maybe tomorrow or at the end of today's class, and you will see why it's required to mention public there before the keyword class. But don't worry about that for now. We just concentrate on how we define the class. So this is how we have written the class. Now it's important to write a main method, right? So if you have come from a programming background, or if you have at least programmed in C or any other programming language, then it's often the main method that executes first, right? So when you execute this class, by default the Java virtual machine executes the method named main as the first method, and that is where the execution really starts. So how do we really write the main method? The way we write the main method is by writing a template like this. We write public static void main and we do this. So what this basically says is we are writing a method. We discussed about methods in our first class, right? We understood that a class basically has a set of attributes and a set of methods. This is the default method that is present for a class, which gets executed first when you execute this file. So we write the name of the method, and we said we also pass arguments, right? So this is one of the arguments that it's passing. Now this argument is basically an array, right? I hope you all understand the concept of an array. An array is basically a collection or group of similar elements, and the kind of elements that are there here are neither integers nor float. They are actually strings. It's a collect, so it's basically a group of strings that are together in this variable called args, and it's passed as an argument to the method main. Don't worry too much about these keywords. We are going to go over them. Public is the same as public that I just spoke here, and static basically says that all objects of this particular class are referring to the same main method. They don't have their own footprint. Right? Don't worry too much about that if you don't understand. But every method is supposed to return something to you, right? It's supposed to take something as input, do something with it, and then return back something else. The something else that is returned back has always a particular type, right? It is either an integer that it gives you back, it's either a float or a double or whatever. So here it says that this method is not really giving us anything back. So that's the reason why we mentioned this as void. And this is how we declare the main method. Inside this, let's do some processing. Let's just print hello world, right? The way we do that in Java is we write system dot out dot println and then we write hello world. Okay, so basically what it's saying is you go to the package system and then go to the class out and then go to the method println and pass an argument to that and execute it. So when you execute the println method of this particular class, the existing libraries that are there in JRE system library will ensure that hello world is printed onto your console output. You will see that now. We have still not executed this code, but when we execute it, it actually prints hello world. So this was a very simple class that we've written. We've declared a class, we've uh, defined a method with the name main, with a standard system method that is there. We have passed an argument, which is basically a group of strings as an array, and we've named it as args. And then we have printed hello world. Of course, there's no significance of args here. We have not used it, so do not bother about it. And now the question is, how do you actually run it? So once you've done this, the Eclipse editor, where you actually write your Java code, automatically keeps compiling your code as and when you write. So ensure there are no errors here. Now the way you ensure that there are no errors is you go to the problems tab here, and then you ensure that this is all empty. So it says 0 items. If you say no errors, your code is fine. So how do you run this? Very easy. Go to run as, and then you click on Java application. Okay. So when you click on Java application, the Eclipse, which has the reference to the Java virtual machine, version 1.7 here, will actually run this on the Java virtual machine, and any output that you get will be in this console tab here, similar to the problems tab that you have. It is the console tab. So if you consider a console tab, you see that it actually printed hello world. So now you have run your first Java code, right? So the first Java code that we ran as part of this course is by creating a sample class. We named the class as myTestClass1. We defined a main method inside the class. We passed argument to the main method. We said the return type is void because we're not really returning anything here, correct? We're just printing something on the screen. And so we said it's void. We are not interested in returning anything back. And what did that method actually do? It actually printed something on the screen. That is a very simple execution. That is a very simple processing that it did. Let's go ahead and create some variables here, right? So let's create an integer. Basically, there are the following keywords in Java. If we really have to create various kind of variables, right? Now the variables themselves are of various kinds, right? So what kind of variable can you think of? For example, there are Boolean variables, right? When you say Boolean variable, the value of the variable is either true or false. The way you do that is by writing the keyword Boolean, and then you say my Boolean variable, right? And then you assign the value true to that. You could also assign the value false, right? There is a character variable. So this kind of variables, which is of type Boolean, will hold the value of either true or false. There are character variables. There is a byte variable. Okay, there is a short variable. There is an int. There's a long. There's a float. There's a double, and so on. So all these are the kind of variables that can be defined in Java, and each of them have their own significance, right? I'll send down some reference links where you could read more about this. They are basically meant to hold different kind of values. Right? One of them holds just true or false, another holds just characters, another holds just integer, another holds just an integer which is of a larger length, and so on. And then if you just declare it with this keyword and write the name of the variable, and then you assign it to a value this way, then that variable will hold that value. For example, here if I want to print the value of a variable, then again I write system.out.println of my, ensure that you don't give a quotes or else it will treat that as a string. If I do this and I run it, then you see that the value of the variable is false, which got printed here. Instead, if you wanted to print the character variable C and you run it, you see it actually prints the value of the variable here. So what did we do now? We just created a value of a variable and we printed the variable here. So we have come a bit far now, right? So we have declared a class, we have mentioned a method, we have passed arguments to the method, we have defined variables, we have assigned values, we have printed it on the screen, and so on. Let's do some processing with this, right? So let's create an int variable here. So int myInt is equal to 5. Okay, and here instead of printing C, let's print myInt, and let's do some processing. So the various kinds of processing that we could do is maybe put something, and everything gets executed here, so we can process some things here. Now this is clear, right? So you see, when we executed this code, it always goes to the main method. Nowhere I have mentioned to the compiler or the code for it to go and pick up this main method and execute it. So this happens to be the default method that always gets executed. Now let's go ahead and actually declare another class here. Okay, and then try and execute a method of that class from this class. Okay, let's create another class for another class. Okay, so this is another class that is there in the same file. Remember, the name of the file should be the name of the class here, which is actually public. The other class should not be public. There can only be one public class, source file. So we have created another class here. Let's mention its attribute. Okay, so let's say its attribute is size, and it also has an attribute called name. So size is of type int and name is of type string. Okay, now let's also have a method. So one of the methods, let's say what this does is void test value is one of the methods. And what does this method do? It says if my size is greater than 50, then print greater than 50 on the screen. Okay, else if my size is lesser than 50, okay, then print equal to 50. Else, if neither of these conditions is true, just go ahead and print I and this should be equal okay. So what have we done here? We have created another class. We have given the class a name. We have said that the class has two attributes. Remember, we discussed classes have attributes and methods. So this class has two attributes. It has a method. The name of the method is test value. And what does the actual method do? Very simple, right? It basically tests the value of the variable size. If it's greater than 50, it prints on the screen I'm greater than 50. If it's equal to 50, it prints on the screen I'm equal to 50. And if neither of them is true, it prints on the screen that I'm equal to 50. These are a set of if-else statements, right? This is similar to if-else statements in any other programming language that you may have written. Every programming language or scripting language that you use either in QA or development would have these statements. It just says if this condition is matched, do this, else if this condition is matched, do this, else if neither of them is matching, then straight away go ahead and do it. Okay. So let's go ahead and kind of run this method here. So what I'm going to do here in my test class 1 is I'll just select this code and delete it. So this is an empty method now in main. So what it does is, let's create an object of the class that we just created. So we say the way you create an object is you mention name of the class, and then you write the name of the variable which is actually your object, and here we put the name as my object. You put an equal to sign and you use an operator called new, which is you're creating a new object, and then you repeat the name of the class like this. Okay, so we have created an object, and this object is of type which class? It's of type another class. And where is this class named another class? This class named another class is in this file. This is the class. Okay, it starts here and it ends here. This complete thing is a class. How many sections does it have? It has 2 sections. There is a variable section and these are the methods. I have just one method. You could always have another method which we'll add now. And where have we created an object of this class? Inside the main method of this class called myTestClass1. How is it able to see this class? It's able to see this because it's in the same file, and that's why it doesn't throw you any error saying that this class does not exist. Okay, so how have we created an object to the class another class? We have written the name of the class, given a space, wrote down the variable whose name is anything that we want, which is actually an object of type this class, given a space, written equal to sign, given a space, we wrote the keyword new, new, and then this class. So now we have created an object of type another class. How do we execute that particular method of the class? So we write my object and we put a dot. So the moment we put a dot, we can access the variables and the methods. So which variable shall we access now? Let's access the size variable, and let's say we assign it the value 50. So what have we done here is we have accessed the size variable and we have said just assign the value 50 to my object.size. So the size variable of that particular class, another class, gets the value of 50. So let's go ahead now and also run the method. So similarly we put a dot, and instead of writing the name of the variable, we write test value. So what happens now is it goes ahead and executes that method of test value. And let's go ahead and run this. So you can just right click here and go to run as Java application. So it says I'm equal to 50. Yes. So how did it get to know that it's equal to 50? Because here the variable size got the value of 50. So inside this object, what Java did is it stored the value 50 for this variable, and then I'm telling it to execute this method. So it go to this method and start executing from this line until the end of the method. So what does this logic say? It says if size greater than 50, what is the value of size? This object had already assigned the value 50 to its size variable. So will this condition match? No. It will come out to the next condition. It will check if size is equal to 50. Is it equal to 50? Yes. So we'll go ahead and execute the code that is assigned to the else statement, which is I'm equal to 50, and come out of the method. So here's where you get the output. To understand the concept of objects and classes clearly, what I'm going to do is I'm going to create another object of type another class. Okay, I'll say my object underscore 2 is equal to new another class. Okay, so what I'm going to do here is I'm going to write my object underscore 2 dot size is equal to 17. Okay, and then I'm going to write my object underscore 2 dot test value. Okay, so what do you think will happen now? Can you tell me what statement will this print, and what output will this print? Will the first one say it's equal to 70, or will the second one say it's equal to 50, or what? Can you guess? Just try. I'm just gonna unmute you all. Give it a try. Give it a try.
It says that it's greater than 50. Second statement. First statement obviously is I'm equal to 50.
So first statement says it's equal to 50, and the second statement says
greater
than 50. Right? Absolutely right. Now, what is important to remember here is an object maintains the values for variables for only itself. Okay, it doesn't share these values with other objects, and that is the main strength of object-oriented programming. Wherein, when you create these objects of type another object, each object is independent of another object. Okay, so if I run this code now, the first statement says I'm equal to 50. Now the second statement says I'm greater than 50. Even though we changed the value of size here to 70, we have changed the value of the size for this object, my object too, whereas my object has not got disturbed. So again, if I execute my object dot test value, you will see that it still says it's equal to 50. Here. Okay, that is because even though 70 was assigned to the size variable, the variable to which 70 was assigned belonged to the second object, which is my object underscore 2. The first object still had its own value, and so it retained its value, it did not disturb its value. And this is the main point that I wanted to bring out in today's code. When you write Java code and you start creating objects of classes, each object is independent of another object, even though both the objects may be of the same class. And when we move into the concept of inheritance and polymorphism and so on in this course, you will see how you can actually enable communication between these two objects. How can these objects pass on the value of their variable to another object? We will see that happening, but we are not there yet. But for now, just try to understand the structure of this Java code, because this is the typical structure we'll be using when we actually look at the Hadoop code and start running it. What we'll have is typically one of the main classes, which is a public class, which is also called as the driver code inside a Hadoop code. It will have a main method that actually gets run when you run the Java code. And inside the main method, what we'll have, we'll be having references to the mapper class and the reducer class, and we'll be calling various methods of the map class and the reduce class, which actually does the map stage and the reduce stage in the Hadoop framework. And then at the end, we'll be saying, go ahead and run my class, and then it goes ahead and runs its map method, reduce method, and finally brings the output. So these are typical structures that we need to be sure. If you have any doubts, feel free to ask that right now. Just to summarize, we have the main class, the main method. We have created objects of another class defined in the same file, and we have modified the value of few variables that are there as part of those objects. And you've seen that the objects act independent of another object of the same class. They all retain their own value and they don't get disturbed if I assign a different value to the same variable of another object of the same class. Is this clear? Do you guys have any doubts? If you have any doubt, please go to ask that right now.
Carry on.
Okay, so what I'm going to do now is I'll introduce the concept of a package, okay, which is specific to Java. I don't know how many guys of you are quite familiar with the concept of a package. How many of you know how to create packages in Java and then specify which package does this code actually refer to? If you already know, then
No, Prashant, I'm not aware of that.
okay, no problem. So when we actually write source code for Java, right, what we've done here is we have written classes and objects. But sometimes there are millions and millions of classes. Sometimes there are at least hundreds of classes that we write as part of a huge Java project, right? And we can't keep going on writing these classes in the same file from top to bottom. It will become one huge file which will be difficult to manage. So what we typically do is we group together classes as part of packages. And a package is nothing but basically a group of classes, right? And how do we say which package are these classes which is there in this file belong to? We just go to the top of the file as the first line and we use the keyword package and we mention the name of the package. So if I say package says my package, it actually goes ahead and sits in this package. But I had to create that in the beginning itself. So now it says, if I just hover my mouse here, it says this declared package does not match the expected package because the expected package is the default package. So it tells me two quick fixes. So it says you can either remove this, in which case the statement gets deleted and you go back to the original state, or you can actually move this file to a package called my package as if you had to create it in the beginning. So when I click on this, you see that under the source folder it creates a package. This brown color check box that you see here is actually a symbol for package. So inside the source folder you have a my package, and when you click on this, that is where this is there. This was initially present inside the source folder, right, with a package named default package. But now it goes ahead inside a package named my package. If I go ahead and click on the source folder and go to file and create a new class here, let us go ahead and create a new class. So let me say my test class 2. There is a space here on this panel for me to mention the name of the package. This is what I left blank when I initially created my test class 1. So now let me kind of create another package named my package 2. So what happens when you click on finish is you see it created a new package named my package 2, and then what it's done is under my package 2 it has created this new class named my test class 2. So it's important to understand the source folder structure here inside Eclipse, right? If I collapse everything, your project has the source folder and the libraries folder. Inside the source folder it has two packages, my package and my package 2. Inside my package it has my test class 1. Inside my package 2 it has my test class 2. Okay. So now we have created packages and then group classes together. There are some things that are important to remember in this scenario. Number one is a Java file. I'm not talking about a Java project, I repeat. A Java file can have only one public class. Okay. Now you cannot use this keyword public for any other class that you may write here. If I use the keyword public here, it immediately throws me an error. And the error says the public type class must be defined in its own file. That means the name of the file should be the same as the name of the public class. And therefore the name of the file here is the name of the same class here. And therefore I cannot use the word keyword public for the class here. Similarly, in my test 2, the my test class 2, which created this class and by default it has named public. I can also create a public static void main string args here method, right? I can do a system.out.println my test class 2. Okay, and I can run this. So if I'm in this file, if this file is selected and I go to run, and I go to run as and click on Java application, the code inside this file actually gets executed. Basically what happens is, in this file it searches for a main method, and if the main method is present, it will go ahead and run that. You see, none of the code which was written in my test class 1 got executed, right? It did not execute this main method. It just executed this. If I want the main method in this class to get executed, in this public class which is my test class 1, I should come out to this file. I should right click on this, or else go to the run option and then say run Java application. And that is when this code gets executed. So see, we have come a long way now, right? From understanding from a theoretical perspective as to what a class and an object is, we've come a long way. We have created a Java project, and we have said we want to manage the code by creating two different packages, because they are kind of two different independent codes for us. While the first package, my package, has the first class, my test class 1.java, we have created another package, my package 2, which is another class called my test class 2.java, and we have independently in these two public classes independently written the main methods, which do two different things, and we had control of which main method to run, correct? We ran in my test class 1 and we then ran in my test class 2. So that way, this is how code is typically managed in Eclipse. As you guys requested, it was important to look at Eclipse and the code here. So any doubts so far? Any kind of a doubt? I'm just going to unmute this. Why don't you just look at this code before it for a couple of minutes in case you have any doubt. Because if this structure is clear, everything else will be clear when you look at a huge code. It will be very easy to understand. But if this structure is not clear, it will be difficult for you guys to understand what really is written in the Hadoop Java code.
Yeah, is it possible to access the class defined in one package from another package?
Is it possible to define?
No. Is it possible to access the class defined in one package from another package? So now here, like we have my test class 2, right? So can we access that one from my test class 1?
Yeah, we can do that. Let me show you how you do that. Let's take up that exercise. So let's try various things, right? So let me try to create an object of class my test class 2 here in this main method. Okay, my test class 2. Class 2 object, which is equal to test class 2. Okay, so we have created this object, and let's run my test class 2 object dot a method. So before we run that, let's go ahead and create that method. So let's say we want public void just in this. It says system.out. Okay, and inside test. Okay, we'll come here. Let's say my test class 2 object dot just So let's run this my test class 1 and see if it really prints this. There is no error. So let's run this. So what does it do? It goes to the main method. It executes this method first. It says I'm equal to 50 because this object has its size variable equal to 50. It will come here. It will execute this method, which is my object 2.testValue. It will see that its size variable is 70 and therefore it says 150. And then it will execute the test value of my object again. And to show that these objects are independent, it says I'm equal to 50. And then we are actually creating an object of my test class 2, which got created here. And it will run the just print this method of my class 2 object. And then what does that method say, which is in another package under the same project? It says, hey, I'm inside my test class 2, and that got printed. Is that clear now?
Yeah. So I mean, like, so that means like this package is just a logical separation. That means like we are grouping classes in one package, but still like whatever the classes we define in one package can be accessible from other package, right?
Yes, but with a small correction.
Okay.
Let's go ahead and create another class here. Of course, it cannot be public because we already have a public class in this file. So let's create another class. We will say my another test class 2. Okay, and we will create a variable for that. So int var2 is equal to 10. That's it. And then we will create a public void print this also. And then if var2 is greater than 10, system.out.println greater than 10. Else, if it is not, then system.out.println not lesser than or okay. So what have we done here? Inside this package, which is my package 2, we had one main, we had a public class, and we saw that we were able to create an object of this and then access the methods. We have created another class. We named it as my another class 2, test class 2, and we defined a variable, and we also defined a method which does not return anything, and we have named that method as print this also. Let's try and create an object of type my another test class 2 here. Okay, so after this, let's go down and say my another test class 2, right? My another test class 2, my class 2 object my another class 2. Oh, it throws an error. You see this? It's unable to create an object. It says, I don't know where this class is, I can't see it. My another test class 2 cannot be resolved to a type. It says, I'm sorry. You are inside my test class 1. So it says, I'm inside this package called my package. You're trying to create an object of type my another test class 2. It says, I'm sorry. I don't know where this class is. It's not visible for me. So the answer is, you cannot always access all the classes that are there in a different package from this package. what kind of classes can you always access? You can access only those classes which are public, which the world can see, right? This class is not public, so this class is visible only inside this class. You can access this class only inside this class. Here you can create this. Another test class 2, you can create this here. Let's say my another object of test class 2 equal to my another test class 2. Here you can do that. Dot print source. Then you can execute this code here, like before. Right? So let's clear that error, or else it doesn't allow us to do that. So here it says I cannot see that. So is it clear at least now? So the answer to your question is you can access classes that are there in a different package in another package only if the class that you are trying to access is public. Any other class which is not public cannot be accessed. Does that answer your question?
Yeah, I got it. Yeah.
Okay, so now Java gets really interesting, right? This way of, encapsulating the classes with objects which are independent from each other and managing your code by creating something which is private and exposing only that is public makes Java a very strong language to program. It allows you to create various kinds of access privileges, right? So that is why when you create a class, an object of a particular class and hit the dot operator, there are only certain methods that you can access, but there will always be hundreds and hundreds of other classes that do some kind of processing but is not visible outside the class. So let's go ahead and remove this because this is not something we are about to do, and we will save this file. We'll come to my test class 2. We'll right click and do run as and Java application. It says my test class 2 because it has come to the main method and printed this, and then it says I am lesser than or equal to 10. Why? Because I have created an object of type mine, another class, test class 2, which is there in the same file, that can see because it's in the same file. And then it has gone inside this method and printed the appropriate statement because it's equal to 10. This is not, this is false. So it comes to the end statement and it says this. Is this clear now? Similarly, you can always create an object of this class in that package, right? You can always create my test class 1 here because that is also public. So inside this main method, if you say my test class 1, my test class 1 object is equal to my test class 1 you can always access the methods here, right? So my test class 1 did not have a method other than the main. So usually it's not safe to call the main method. So if you create another method here saying something like public void print my method and say system.out.println am inside my test class 1. You see, I am now trying to access the method, which is print my method, and if I run this, you see it says I am inside my test class 1. But if this is not public, right? If it is just void without public, you immediately get an error and it says, hey, I can't see this method. I cannot do this. You see this? That is why these keywords such as public is very important, because it's also known as an access privilege inside Java. It's related to how much privilege you have to access that. So you see this? It says, I'm happy to create this object for you because I can see this my test class 1 because it's in another package and it's public, but I cannot see this method that you're telling me to execute, print my method. So I cannot do anything about it. So what do? You go there and you put public, and then it says, okay, I can now see this method. I can run that for you, and then it runs that. So even though you can see the class, you can restrict the visibility of the methods by removing public out of it. Okay, that is why it's important to have something as a public, and maybe not to have public for something else that you don't want to see. There's a class called another class here. Can you access another class here? What would be your answer? Yes or no? Can I access another class here? Can I create an object of another class?
Yeah, we should be able to.
You think you should be able to?
Yeah.
We tried to create an object of my another test class 2 inside this class in the main method. It threw an error. Why do you think we will be able to create a object of another class inside the main method of this class when it's not public? It says, ouch, I cannot see this class. Why? It's because of the same reason as to why we couldn't create an object of my another test class 2 inside this file. The same reason as that, because this is not public, right? It's not a public class, so I cannot create an object of the class. Is that clear now? Yeah? Krishna?
Yeah.
Okay. Great. So this is what I had planned for today's class. There is some amount of learning here. I'm sure things might kind of look a bit confusing. It's very easy to forget these things. So I would advise you guys to please revise this. Go through some of the material on the web about creating classes and objects and access privileges. Try to see, besides the keyword public, what all are the other keywords such as private, there's something called default, there's something called protected, and so on. So just go ahead and try and do some research and try to understand what all do the other kind of keywords access privileges also do, because it's important to understand what the other access privileges also do besides just publish. And try to write some code inside Eclipse, experiment with it, try to change things here and there around a bit and see what happens. If you get an error, try to resolve that. So that will help you clarify things better. And if you have doubt, anyway, we always have another class tomorrow, right, for you to ask the same doubt. So that's it, guys. I hope this was useful. To just summarize, what all did we do today? We looked at Eclipse, we saw how to create a project, we create packages, we arrange the classes in their respective packages, we created objects of classes, we tried to access methods of one class in another class. We try to create an object of one class in another class. We change the keyword public. We try to remove it. We saw what that happens. We created more than one class in the same file. We try to access various different classes at various different places. We change the values of variables assigned to objects. We saw objects are independent of another object which are of the same type class, and we declared the name of the package. We resolved errors and so on. So we will go over some other concepts tomorrow. We will look at maybe inheritance, where one class tries to inherit everything that is there in another class. We'll try to see what advantage that has, and then we will keep going forward from there. Any doubts? So far, do you guys have any doubts? Was it all clear? Okay, great. So I'm going to end the session. Let's meet tomorrow at the same time.